All right, learning target 9D. We're going to finish strong here with our last learning target of Unit 9. More trigonometry. Here's the deal with these. You got to look at what you're given. If you look at number 12, I'm given a 9, I'm given a 4. I'm also actually given one more thing, I'm given a right angle. Now, if you realize it says solve the right triangle, that means find everything. There are 6 parts to a right triangle, 3 sides, 3 angles. So I already have one of the angles and 2 of the sides. Okay, so here's the deal. Every problem is different, but this is the kind where we realize, this is the kind that we realize that we can find a side not using trigonometry. So there's always one thing we can find without trig. So what I'm actually going to do first is b squared plus 4 squared equals 9 squared. And I'm just going to find out one of the missing parts the way I know how, with Pythagorean theorem. So b squared plus 16 equals 81. B squared equals 81 minus 16. So, oh man, that was a tough one for me. 81 minus 16 equals 65. Then I take the square root of both sides, so b is approximately, all right, well, I really just wanted to show you how you can do square root of, if you hit control and then this negative one, you'll take the square root of your answer, so you can hit enter, and that actually comes out to 8.06 when we round here. So we should have no problem finding the third side of a right triangle when I'm given 2. All right, so here's the deal. Don't think about b anymore. We're done with it, okay? But now when I take my highlighter and I actually focus in and try to find, that thing's bothering me, sorry. Let me get the green one here. Let's try to find theta first. Okay, let's focus in on theta. From theta, what do I have? Well, look at your yellow things highlighted, the numbers you have. I have opposite, I have hypotenuse. Opposite hypotenuse, so what's that going to be? We know that that's going to be sine. So remember, sine equals opposite over hypotenuse, cosine equals adjacent leg over hypotenuse, and tangent means opposite leg over adjacent leg. So on this problem here for theta, if I just focus on theta right now in this area, I'm doing the sine of my angle, always of the angle, sine of the angle. Okay, sine of theta equals opposite 4 over hypotenuse 9. So to solve this now, I wave that magic wand and I say theta is equal to sine inverse. If you're still not understanding this, I suggest you watch Learning Target 9C's video. I talk about this in there as well. But the calculator knows stuff here. We don't multiply both sides by anything. We literally ask the calculator, what's the angle? And unfortunately, we can't just say, what's the angle? We have to tell it some math. And using this inverse trigonometry, we actually are telling it that we want an angle. So sine inverse, and then we just type in 4 divided by 9. And then we hit enter, and there it is. So theta in this case is approximately 26.3878. All right, so let's go 26.3878 is going to be 0.39 when we round there. All right, so now we got to find beta. All right, so this work's going to be for beta. Well, let me grab a different highlighter here. Let's go with blue. Now I'm focused on beta. Well, now I want to look here and here. Getting a little dark there, sorry. So 4 and 9 again, but this time it's not the opposite in hypotenuse. It's the adjacent in hypotenuse. So I know that the adjacent in hypotenuse gets me to cosine. So this time it's cosine of beta equals adjacent 4 over hypotenuse 9. Again, magic wand time. Not really a magic wand, but you're just telling the calculator, hey, calculator, I'm looking for an angle. I know the ratio of the sides is 4 to 9. So then we go to our trusty calculator. Trig is cosine inverse. And then this time we type in 4 divided by 9. We hit enter. and beta is approximately 63.61 degrees. I really should have put degrees in that other one, sorry. All right, so now if we look at these two angles, I want you to notice something. All right, let me just check these. 26.39. That's the answer I got for theta. This is very important. Plus 63.61. If I hit enter, look at that. 90 degrees. That should not shock you. Theta and beta are two angles here that when added with a 90-degree angle, we get 180 degrees. These two are supposed to be, fancy term, complementary. Hey, you're doing well, theta. Hey, you're doing well, beta. No, that's not what I mean by complementary. By complementary, I mean that they add up to 90 degrees. Okay? So that's a good way to check and see if your work is correct. All right, great. I hope that helps. All right, now let's look at this other triangle here. Excuse me. Now, all right, so Mr. Powell said just do Pythagorean theorem. Here we go. We can't just do Pythagorean theorem here. So I'm going to take out the green highlighter, and I'm going to highlight up 19, got 12, and then again, obviously, we have the right angle. Well, unfortunately, we don't have two sides, so we can't do Pythagorean theorem right away. But if we take this yellow highlighter and say, what about this one? Can we find that very easily? And the answer is yes. So how do we find theta very easily? Well, think about this. Looking for theta here, you know, and there's different ways you guys can think about it. But if you look here, what I just said a minute ago for number 12 is that these two angles are complementary. Sorry, yawning here. Sorry about that. Theta plus 12 degrees is equal to 90 degrees. All right. Well, what's theta equal to then? Well, theta is equal to 90 minus 12. So if we do 90 minus 12, we actually get 78 degrees. So we're able to find theta very easily without using trigonometry. That reminds me of this last problem where we found, what was it? B very easily without trigonometry. So remember, we start each of these problems with no trigonometry, finding one of them. And then we say, all right, let's forget thinking about that. Okay? So here we go. I don't know if this eraser will work. Good, it will. Okay, so what I want to do now is I'm going to grab a different highlighter to do each of these. So I'm going to grab blue now. I'm going to say, all right, we have 19, we have 12, and then what do you want to look for first? Well, I'll do A, because it's alphabetical order here. Excuse me. So we take our pen, and we say, all right, I've got, I'm trying to find. So I have the hypotenuse, definitely. I do not have the opposite here. Forget about B. I'm focusing on A. Remember, there's 3 separate problems to do here. I can't do it all in one shot. So I just say, all right, let's get A. This is the adjacent and the hypotenuse. Don't forget, the adjacent and the hypotenuse is cosine. So here's cosine, always of the angle measure. So this is 12. So cosine of 12 is equal to adjacent over hypotenuse. So that would be A over 19. All right, well, this is the real easy one because it's all good. Variable on top. Multiply both sides by 19. All right, so now I just go to my calculator, and it's going to do the rest of it for me. 19 times trig cosine of 12. Enter. Sweet. 18.584. So that would be just 5/8 approximately there. Okay, so here we go. Let me get this eraser out again so we can look at this very clearly. Forget about A. I just found A. So now if I bring this back, hold on, sorry. If I get this blue out here and I say, let's now find B. All right, so now I don't have the adjacent, but I have the opposite. Opposite, hypotenuse. And now for this part of the problem, I'm thinking so, which is obviously standing for sine. So sine of 12 degrees is equal to, all right, what is that going to be? That's going to be B over 19. So B over 19. All right, so looking at this problem, sweet, variables on top. Here we go, times 19, they cancel. times 19 on this side. And then I'm going to do this exact same thing, except for now it's 19 times not cosine, but this time, sorry, it's just sine. So sine of 19 times sine of 12. Hit enter, and it looks like B is approximately 3.95 if we go to 2 decimals. Okay? And then if you really want to take extra time right now, make sure you're doing well, which is awesome. You can always take your values. I have an A, I have a B, I have a C. Shouldn't Pythagorean theorem work? You could just, for the fun of it, try this squared plus that squared and see if it comes out to 19 squared. Never a bad idea to check all of your work there. Okay, one last thing I want to say before I end this video is, it didn't happen in this situation, and just like I talked about on the Learning Target 9C video, what if this would have happened? What if we would have been doing the problem and it was cosine of 12? Remember, I want to be clear, these are done. These are our answers. Now, Mr. Powell, like I often like to do, is doing a what if scenario. What if we were doing it and it said cosine of 12, and I'll just make up numbers here, and it said 14 over A. Well, if the variable's on the bottom, remember, little bit trickier to solve. Multiply both sides by A. Then after you have this really says A times cosine of 12 equals 14. That's where you want to divide both sides by cosine of 12. So divide that side by cosine of 12. I'm running out of room, so I'm not showing that the greatest here. But to find A now, all you would have to do is you would have to put this on your calculator, which is 14 divided by cosine 12. So I'll show you how to do that. 14 divided by trig cosine 12, enter. And you can see up here, that's what it looks like. It would be 14.31 if we were doing that problem, okay? So it's just another way to solve if you get the variable in the bottom. I really hope this video helped you. This is a tricky learning target. There's a lot going on. If you're still having issues, either rewatch it, go back through it again, try other problems, or see me for help. I'm always here to help. Thanks.